type of neurofeedback. That's why we want to do it. We don't want to have somebody like the boy they referred to me in the show that they're giving medications without even knowing what type he has. We want to individualize it to the brain and not guess based on the symptoms. Because all these symptoms, believe it or not, if you and the teachers fill out a questionnaire, could look exactly the same on the surface. Let me show you what we get. What we get, first of all, is we get statistics on the brain. So the Q in the EEG means quantitative. We do statistics. So this is a child, because people always say, what does a child kind of normally look like? This is a child who didn't have ADD, whose parents thought they did. He actually had a lot of motivation problems, and the parents had totally different parenting techniques, and there was a lot of stuff going on at home. Each of these boxes are one of the 19 electrodes, and this is a theta to beta, a daydreaming to attention ratio. It should be between, for a young child, between 1 and 4. For an adult, 1 and 2. These were right where they should be, 1.4, 0.9, 1.8. This is good. The daydreaming and attention were about the same. That's what you want. And this is what this child's brain map looked like. All these circles were green. You see this little color code? Green is average, blue is low, and the kind of the red and the oranges and yellows are high. It's like a temperature scale kind of looking. So this is a picture. This would be the nose. Each of those dots is one of the 19 electrodes, and we measure them exactly where they should be. And the ears would be here. And it breaks it down. This is a summary into 4 different types of brain waves. The delta, which is kind of a sleepy brain wave. The theta, which is that daydreaming brain wave we see high if you have ADHD. The alpha, which is more an inattentive brain wave and sometimes depressive. And the beta, which is the zone brain wave. And you want them all to be balanced. Now, most people with ADD are going to have an imbalance pattern. When I look at the statistics, their daydreaming to attention ratios, this was an adolescent, were 3 to 4 times as high. When I looked, so that's too high. The daydreaming was 4 times the attention a lot of places. When I looked at their brain map, this is a classic person with ADHD. The theta, the daydreaming is high right in the frontal areas of the brain. The frontal areas of the brain are where your executive functions are. Your organization, your impulsivity, your attention. So that part of the brain had too much daydreaming. And this is a classic ADHD pattern. Now, we could have a child whose numbers look the same, but they have an opposite pattern. On the bottom, you see the red here, and this is an anxiety pattern or an over-focus pattern. So the boy in the doctor show, Noah, actually had both of these patterns. He had hyperactivity, and he also had some kind of anxiety going on too. Now, someone who's depressed might have their high activity over in this area, in the alpha. See, the problem with the medication is you can't pinpoint where for the medication is to work, right? With the neurofeedback, we can actually pinpoint if we're going to lower the anxiety in the back, or the hyperactivity in the front, or if we're going to go to the inattention that's in this area. We can actually individualize it without aggravating the other parts of the brain, as I'll get into. Now, we could have a child with ADD and learning disabilities, and this was a child who had issues with lots of other areas. So everyone's brain pattern is different, although when I test people in families, I do see similarities in their patterns. So it's kind of like a fingerprint. You can get a sense of what's going on, but sometimes, like with the boy in the doctor's show, he had a seizure disorder underlying. And when his teacher said he was staring, that was a sign, really just staring more than daydreaming. If you remember the video we talked about and you watched him, he sat there, kind of gazed a little, kind of with his eyes would gaze. And even when I watched that show afterwards, I think he was doing that while we were recording it, which is why we could pick it up. You could see it on the video a little bit. Now, what about autism? In the article we have coming out, actually supposed to come out at the end of June, we found up to 6 different types of autism. So it's much more complicated than ADD. I think this is why they're having such a hard time finding medications that work. They really haven't developed one yet, but there's so many different patterns, and it ends up, when we work with autism, most people have at least 2 of these patterns, sometimes 4 or 5. The most common type is what we call the high beta type. Beta is the focusing, but if it's high, you're over-focusing. You get stuck in things. You can't transition. You obsess about things. Another common pattern we see is a high delta theta. Theta is like hyperactivity, but delta's the slower brain wave. I call these the really hyperactive autistic kids. These are the kids who run around. They're 5 times as hyperactive as an ADHD child. My office manager, Mark, will remember we had a boy that came to see us from out of town. I think he was from Canada. And we have about 13 different rooms in our main office in San Juan. And he walked into every office, opened the door, turned the lights on, shut the door. I mean, he did this running. Mom was chasing him. I think my office manager, Mark, was chasing him. He ran all through the building, locked people in the bathrooms. So how am I going to talk to this kid? I need to get him to overfocus. We have a portable DVD player, and I put it in front of him, and I was going to let him watch a movie thinking he could just look at me. Before I could even get the thing started, he says, "Me do." And he opens it up, he puts it in, and he found a shortcut on the DVD player I had never seen, using it for 2 years. He was very good, kind of mechanical. The seizure type. A seizure type, and I'll show you, we're looking at the raw EEG. What we and other people have found is about 1/3 of autistic students, not Asperger's or ADD, 1/3 of autistic students have abnormal EEGs that are sometimes seizure disorders. Over the years, I've seen a number of kids that had seizure disorders, and when the seizure disorders was treated, they talked and socialized, and it really wasn't autism, but it ends up a lot of times there's both. And if you take a stimulant or any stimulating medication, that can aggravate that or lower the seizure threshold and make it worse. Then there's a metabolic toxic type, which I'm glad isn't that common. Theoretically, this is what we might see with a certain percentage of people that may develop autism from environmental influences like the thimerosal or mercury in a vaccine or something in the environment like pesticides or pollution. There's a lot of theories about this. Actually, I saw someone this week that had this from a kind of an Epstein-Barr type of virus that kind of was, again, kind of something that was kind of metabolic. But it isn't a very common pattern. We do see it. And then there's a pattern called coherence, which if you follow autism is getting more interest. Coherence talks about how your brain communicates. There's the front and the back and the left and the right part of your brain communicating. Is it doing the same thing at the same time? People with autism have problems. Parts of their brains are under-communicating and parts are over-communicating. So let me show you what some of these pictures look like. This is somebody with a common type of autism that has too much beta. This red right in the front here, it's very high. It can be the whole area. And instead of lowering that like we might have to do if someone has ADHD, we would want to raise this. With autism, we have to lower that overfocusing. We have to lower that high beta. That's the pattern I showed you in the SPECT scan that was over-aroused a little while ago. This is somebody, these are individual circles. Each of these circles is one speed, so this whole top line is some of the daydreaming. The delta, which are the slower numbers, 1 to 4, are all red here. And that's a kind of somebody that had a lot of delta, like that hyperactive kind of type. This is one example of many that looks at seizure patterns. You see, you want to see the brain waves like this. Each of these lines are 19 electrodes, or each one is where one of the EEGs comes from. And you see where all these lines run into each other here? That is seizure activity, where there's a discharge going on. It could be just in one location. If it's in the left hemisphere, it might interfere with language, or it could be everywhere, like the boy on the video who had an absent seizure, kind of had it everywhere that was going on. And this is the low voltage, and it's kind of hard to see, but the brain waves are really, really small. So one of the important things to know about the QEEG, you need to look at it 2 ways. First, you have to have a neurologist look at the raw EEG, which is what this is. Neurologists are trained. There's at least 50 different types of abnormal EEG. There's no computer program that can do this better than the human eye to date. And then you have to look at the maps, like all the circles, to see the patterns of ADD and autism and Asperger's. What about Asperger's? What we found is there were 2 kind of unique patterns to Asperger's that we didn't see with ADD or autism, although we can see them all together. Now think about it for a minute. People with Asperger's have very good language. And if you know how the brain works, the language is more on our left side of the brain. On the right side of our brain is where more our social and emotional functions are. So what we find usually with people with Asperger's is the left side of their brain is working really well. The right side of the brain, where the social and emotional functions are, is the